FastMCP 3 implements a provider-based component registration system, where the local provider serves as the default storage for decorator-defined tools, resources, and prompts. This architectural pattern enables modular composition by treating each registered function as a discrete component within the server's component graph. We'll examine how the FastMCP class initializes with a server identifier and demonstrates 3 core decorator patterns. At MCP tool for executable functions, at MCP resource for data endpoints with URI addressing, and at MCP prompt for parameterized message templates. The upcoming code reveals how these decorators automatically handle metadata extraction while maintaining component isolation within the local provider scope. From FastMCP, import FastMCP. MCP equals FastMCP my server. Hash these are stored in the server's local provider. At MCP tool. Def greeting SDR. Greet someone by name. Return hello name. At MCP resource data //config. Def get config SDR. Return configuration data. Return version 1. At MCP prompt. Def analyze topic SDR. Create an analysis prompt. Return please analyze topic. This code demonstrates FastMCP's core architecture using the local provider pattern for component registration. The FastMCP instance acts as a server container that automatically includes a local provider for storing directly defined components. When you decorate functions with at MCP tool, at MCP resource, or at MCP prompt, you're adding them to this default provider, which handles automatic naming, schema generation, and validation based on Python type hints and docstrings. The provider abstraction enables component composition and discovery. The local provider is queried first when clients request components, ensuring your directly defined tools like greet and resources like data //config take precedence over those from mounted or proxied servers. This design allows servers to scale by adding multiple providers while maintaining clean separation of concerns. You can later add remote providers or database-backed components without modifying existing code. The decorator approach provides a clean, declarative way to expose functionality to MCP clients. Tools become callable operations, resources become data endpoints, and prompts become reusable templates. This pattern is particularly effective for building modular systems where components might come from multiple sources, as the provider system handles the complexity of discovery and routing behind a simple decorator interface. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which is the main class for creating MCP servers. MCP equals FastMCP my server. Creates a FastMCP server instance with the identifier myServer. The string parameter serves as a server label that will appear in MCP protocol handshakes to help clients identify this server, but does not configure any functional behavior or operational mode. At MCP tool. Def greeting SDR. Greet someone by name. Defines a tool function named greet that takes a string parameter name and returns a string. The decorator at MCP tool registers this function as an MCP tool, automatically using the function name as the tool name and the docstring as the tool description. The type annotation, SDR, indicates the function returns a string value. Return hello name. Returns a formatted string that embeds the value of the name variable into the greeting hello name. This is a standard Python F string that performs string interpolation, replacing name with the current value of the name variable at runtime. The result is a personalized greeting message.
At MCP, resource data //config.
Decorates a function or class to register it as a resource with the URI data //config in the FastMCP framework. This makes the decorated component accessible to MCP clients at that specific resource path. The decorator automatically handles the resource registration in the server's local provider, exposing it for client discovery and access.
Def get config SDR. Return configuration data.
Defines a function named getConfig that takes no parameters and returns a string value. The function's purpose is documented to return configuration data as indicated by the docstring.
Return version 1.
Returns a JSON formatted string containing a version identifier with value 1. This is a simple response payload indicating the protocol or API version being used.
At MCP, prompt.
Decorates the following function as a reusable, parameterized prompt template for MCP clients. The decorator registers this prompt with the server's local provider, making it available to connected clients. FastMCP will automatically use the function name as the prompt identifier and the docstring as its description, while generating an input schema from the function's parameters and type annotations.
Def analyze topic, SDR. Create an analysis prompt.
Defines a function named analyze that takes a string parameter topic and returns a string. The function's docstring indicates it creates an analysis prompt, suggesting it generates a text prompt related to the given topic for further processing.
Return please analyze topic.
Returns a formatted string that prompts analysis of the specified topic by embedding it in the message, please analyze, topic. FastMCP3's provider-based architecture shines through this implementation, where the local provider acts as the default storage for all decorator-registered components. The three decorators, at MCP tool, at MCP, resource, and at MCP, prompt, each serve distinct purposes while sharing the same underlying registration mechanism. Tools become executable operations, resources expose data endpoints with URI addressing, and prompts provide parameterized message templates, all automatically registered with metadata extraction from Python type hints and docstrings. The key insight is how this design enables seamless component composition. By using the same provider system for all component types, FastMCP maintains clean separation of concerns while allowing servers to scale through additional providers. The local provider ensures directly defined components take precedence, creating a foundation that supports both simple servers and complex multi-source architectures without requiring code changes. This consistent decorator pattern across different component types makes the system intuitive to extend while handling the complexity of discovery and routing behind the scenes.
The decorator dreams of unwrapping itself, but the function holds the scissors.